Good evening, everybody, and welcome to another parliamentary and scientific committee discussion meeting, and the first one of 2022. So a happy new year to everyone. Thank you very, very much indeed for joining us. We've got a very interesting and very timely subject to discuss this evening. On the topic of climate change and health, and how we live or survive the rising global temperatures. And this meeting is being organised in partnership with the Physiological Society, who I believe today have launched a new booklet on physiology and climate change. And I'm sure that Andrew will put in the chat a link to that if you would like to take an in-depth look. But to mark that launch, which, as I say, we are here to do today, we have 5 fantastic speakers who are going to take us through some of these issues. The booklet itself highlights or showcases the work of physiologists across the world in the global effort to understand and to find solutions for the effect of climate change. And I'm very pleased that we have people from not only the UK, but also from around the world here with us this evening who can talk firsthand about some of that impact. So you're all very welcome indeed. And I'm sure we're going to have a very interesting and informative discussion, as we so often do. And to kick us off in a moment, I'm going to ask Dr. Marina Romanello to speak to us, but usual rules apply. Please keep yourself on mute unless you're making a contribution, of course. I'm going to ask each of my speakers to speak for around 8 minutes. I will try and keep you to time, because if we overrun even by a couple of minutes on each one, we soon find we're running out of time for questions and answers at the end. So please do your best to stick to time. Okay, I think we are ready to get going. And as I said, our first speaker is Dr. Marina Romanello, who is Research Director for Lancet Countdown Annual Report of Climate Change and Health. And as I mentioned, we have an international flavour, and so Marina is joining us from Buenos Aires, who is, I understand, undergoing an extreme heat wave at this very moment. So, as I said, it's a very timely subject. And Marina is going to speak to us on the impact of rising heat on people around the world. So, Marina, over to you. 8 minutes, please.
Perfect. Thank you so much. And thank you for having me here. I'm delighted to be sharing this with you, because obviously it is what we care the most about at the Lancet Countdown. So I'm going to try to see if this works, and I can probably screen share with you. I'm going to put this down. There we go. You should be seeing my full screen presentation now. Is that working? Awesome. So I am now the Executive Director of the Lancet Countdown, and I work in London, but I'm currently in Buenos Aires, melting, absolutely melting. We are having the most brutal heat wave. And when I was invited into this talk, I was asked to present on first-hand experience, so it is quite timely. I'm going to tell you a bit about our work at the Lancet Countdown on heat, particularly heat and health. And I'm going to tell you how we're living this firsthand in a city like Buenos Aires, and it's quite representative to what's happening in other cities of lower middle-income countries as well. So first things first, the Lancet Countdown. We are a research collaboration, a very big research collaboration. We're global, and we nucleate researchers from leading universities and UN institutions around the world to collect data on climate change and health. And as I said, I'm currently in Buenos Aires. Buenos Aires on Friday hits the second highest temperature on record, only after the 1957 temperature. It was brutal. Buenos Aires is a very, very hot city. What you can see here is the Rio de la Plata, a highly, highly polluted river, the ground of which is mostly rubble. And people were just swimming in the river. It was absolutely boiling. Many injuries. I have a friend that works in the hospital nearby, and she attended kids with injuries from the rubble in the river. Not even to mention about the sewage that gets directly thrown into the river. People here, you can see in the bottom at the fountains in the city, also electrical hazard in those fountains, but it was just unbearable. So at the Lancet Countdown, we track exposure of vulnerable populations to heat waves. Obviously, people over 65 years of age, very young children are particularly vulnerable. And as you can see in both of these graphs, in both of these population groups, exposure to heat waves have been increasing very rapidly, particularly in the last 10 years, affecting almost in the over 65 age group, almost 3 billion more percentage of heat wave exposure in 2020 than an average that finished just 16 years ago. So exposure to heat waves growing really, really rapidly. And in addition to this, we also track people's vulnerability to heat, which is determined, and we define this index according to underlying health conditions that make people particularly vulnerable, heart disease, lung disease, kidney disease, diabetes, and those underlying health conditions that would be tipped over the edge when people are exposed to extreme heat. We also track the elderly population, people over 65 years of age, and urban populations. Obviously, urban centers get particularly hot in hot weather. So people living in urban centers are generally at highest risk. And as you can see in the graph here on the right, in all Human Development Index country groups, vulnerability to heat is increasing really rapidly. And the most vulnerable group is very high Human Development Index country, matching very high income groups as well. People that are very urbanized in these populations, and also that have very high incidence of chronic disease. And with this combo of increasing vulnerability, increasing exposure to heat waves, obviously what happens is we have increased heat-related mortality, and we're seeing this around the world as well. It's important to note, though, that most countries will not report heat-related mortality. They won't report excess mortality. So this is model data. In Argentina, I was just searching for it. We don't report excess mortality in days of heat. So many countries have a huge gap in being able to address those vulnerable populations and understanding where the big risks are. The UK is actually quite good at reporting this, I should say. And now I'm talking about hard outcomes. I talked about kind of mortality. We also have excess morbidity, but what's something really interesting, and with my biochemical background I'm particularly interested in, is the subclinical impacts of extreme heat exposure that are much less explored, and understanding the biomarkers that will allow us to identify highly vulnerable populations. I think for the Physiological Society, this is something quite interesting to understand what is the physiology of extreme heat exposure and what happens beyond those hard outcomes that we're seeing, because this happens more and more often in time, and we can expect this to happen more and more often. And beside the excess morbidity, excess mortality, oops, this got all over the place. What we're also seeing is that because we're having more heat exposure, we're also being more and more limited in our capacity to do exercise or physical work outdoors. So what we're also seeing is that around the world, people are losing hours of potential labor because of this extreme heat exposure. There's a physiological limit to how much work you can do outdoors when it's really hot. And at the same time, we're losing safe hours of physical exercise. More and more hours now, the government recommends that we don't go outside and exercise because of the extreme heat. So both from our kind of mental health is having impacts, our capacity to exercise, and our income, the social determinants of health, are also being put into increased risk. In Argentina, in the north of the country, there's the siesta time, when people go to sleep because you cannot work outdoors, is getting more and more extended. So the light time hours are being reduced for labor in the countryside particularly. And obviously, with the extreme heats, with the extreme temperatures, we're also seeing more and more urban wildfires. And one of the things that is really concerning is that this is happening very frequently in urban areas. And this was just on Friday, when the temperatures hit 42 degrees, it was suffocating, we couldn't breathe. This happened just behind my house. The ground was literally igniting. There's construction work going on all around, and land just back here caught on fire because of the extreme heat and the drought. You can see also here the cloud over Buenos Aires. And what we're tracking as well in the Lancet Countdown data is the exposure of people to days of extreme wildfire risk determined by increased temperatures and drought. And 60% of countries are seeing increased exposure to days of extremely high wildfire risk, very associated also with the bushfires that we saw in Australia, in Canada, in Siberia. And obviously, when we talk about heat, one of the simplest and most obvious way of adapting to heat is increasing urban green space. Green space is incredibly effective at reducing the urban heat island effect, and also at cleaning the air, at giving a space for recreation and giving shade. And yet, when we look at satellite data, we see that very few countries around the world have actually good levels of green space in their urban centers. South America is particularly bad, and Buenos Aires has really low levels of urban green space. In the satellite image here, that's what you can see. There's practically no green space. And the city is a mirror of very tall buildings, and very kind of, the pavement gets so boiling hot. What we do in general is go to the use of air conditioning units, which obviously increases the release of heat waste to the urban centers, increases the urban heat island effect. And what happens is that the power doesn't allow for this capacity. We reached peak electricity demand during the last 2 days of the heat wave. And with that came the blackouts, the power outages that you can see in orange here. This is the bigger Buenos Aires, and this is the proper city of Buenos Aires. We had over 700,000 people without access to electricity. What this means is that people not only cannot use fans or air conditioning units, people living in buildings don't have access to water because you cannot pump the water up. So people were locked inside boiling hot apartments without access to cold water, without even being able to shower. I have a friend whose house recorded 47 degrees that day, and there's no escape in a city like Buenos Aires. Part of this problem is driven by energy poverty and by the informal energy system that we have. And because of this informal energy system, what happens is that the resistance capacity does not work, obviously. This leads to explosions. It also leads to urban fires. And obviously the outages happen everywhere constantly, even if you had enough supply. But just the fact that we have energy poverty and informal settlements is what drives this mostly. So there's a huge combination here. Am I on time, Stephen?
You're a little bit over. If you could start to wrap up, maybe 60 seconds more.
Yes, that's perfect. That's what I wanted to show you about heat health and urban centers. But because I was also asked to talk a bit about what happens in extreme cold, I just thought I won't present it, but I'm just gonna pull you to two good resources. One is looking at what's happening with Aboriginal communities in Canada in particular, with the permafrost melting in Canada, even if it's not in such extreme heat. The permafrost melting is leading to Aboriginal communities in Canada not being able to access food because they get stuck out from areas where they previously were able to access through the ice. The ice melts, so therefore they remain locked in certain areas. Obviously, a huge problem of food insecurity happening now in those Aboriginal communities. And in addition to that, the permafrost melting is also leading to the release of bacteria, of chemicals that were locked into the ice, of heavy metals, and of nuclear waste that was buried in. So really, really interesting read if you want to see what happens beyond extreme heat, but actually the loss of extreme cold as another side of the coin. And with that, I'll just finish and thank you. Apologies if I exceeded.
Marina, thank you very much. That was fascinating. It sounds truly awful in Buenos Aires at the moment. 47 degrees, that is real heat. Just going back to one of your slides, when one talks about extreme heat events, is there a threshold? Obviously 47 is seriously high. Is there a threshold where it becomes an extreme heat event? And do those differ around the world? I noticed on one graph that both Germany and India were red in the number of people whose lives were lost through extreme heat. Was that measured in the same way? Are they, because I can't imagine Germany's the same as hot as India.
No, it's not. That's a really, really great question. We don't have a standard definition of heat wave, and that is a big problem because it highly depends on local adaptation strategies and local acclimatization. What we're using is a definition that the WMO used a while ago, although they don't put up a single definition, but they used it a while ago. That is, if I'm remembering properly, is 3 consecutive days of the temperature being above the 95th percentile of the base years of 1986 to 2005. So it's defined per baseline per country. But one thing that is quite interesting is, I always find this very entertaining in London. In London, when you have 30 degrees of heat, it's impossible to go to a pub. It's impossible to be anywhere inside because the buildings are really not adapted to the heat. So it's the impact that it can have on health, it goes really beyond what the thermometer is measuring, but rather how well adapted you are or not to that. India is particularly well adapted to heat.
Yeah, thank you for that. And just for the record, there is no reason never to go to the pub.
However, in the garden.
Absolutely. Brilliant. Thank you very much indeed. Right, we will move on to our next speaker, which is Professor Mike Tipton, Professor of Human and Applied Physiology at University of Portsmouth and Chair of the Policy Committee for the Physiological Society, and I believe co-author of the report, certainly involved with its production. So, Mike, we very much look forward to hearing what you have to say. If I could have around 8 minutes, please.
Thank you, Stephen. I'm assuming that everyone can hear and see my slides.
We can.
That's
Brilliant.
great. Well, as you say, I'm going to give you a bit of an overview of physiology and climate change, and I'm going to base my presentation on the report that we've been talking about this evening, and just pick out some of the areas that people are working on with relation to climate change. And the first area is the first really part of that report is just to confirm what we already know. And this is a piece that I wrote with Professor Hugh Montgomery, to whom I'm indebted for some of the slides. We know global temperatures are increasing. We know sea levels are rising, CO2 emissions are increasing, and the Arctic ice is reducing. The prognosis is not great. Species extinction, widespread disease, unlivable heat, ecosystem collapse, and cities menaced by rising seas. And it's going to become painfully obvious for a child born today by the time they turn 30. And we can't have a meeting today without at least referring to the UK risk assessment report that was published today that had over 60 risk areas, the main ones being on this slide. I'm clearly not going to go through them in the time available, but it is worth noting that it includes diversity and species diversity, increased flooding and drought, human health, well-being and productivity. I encourage people to read that risk assessment just published earlier today. The next area of the report I just want to touch on is the work that's being done with animals, because this is important, and it's eco-physiology that gives us an insight into the physiological limits of survival and the conditions needed for animals to survive. We know that there has been something like a 68% reduction in vertebrates on the planet since 1970, and heat-related mortality will result in a further reduction in biodiversity, particularly in arid regions. There's a large variation in the ability of different species to tolerate heat, and some of that comes from natural selection of animals able to adapt to both the extremes of heat and cold. And some of this information will be critical for approaches for humans going forward. So there are three interesting areas of research being undertaken by physiologists. There's a complex interrelationship between diet, healthy aging, and climate change, healthy aging being another of the key areas that the Physiological Society is interested in. On the one hand, food production accounts for about 20 to 30% of UK greenhouse gas emissions, and those gas emissions come from every stage of the food chain. Compounding that is rainforest destruction for feeding and grazing, and that removes a carbon sink. And of course, the attraction is to move to more plant-based protein foods, but we need to be sure that protein is digestible, has the required essential amino acids and leucine content. And particularly that's relevant for the elderly who lose muscle mass with age and need to have accessible protein. I think this particular area highlights the really important aspect which we have with most major societal problems of having collaboration and a multidisciplinary approach, of which physiology is obviously a key element. We've already heard about flooding, and we know that flooding is increasing around the planet, and we know that's the case in the UK. A recent Nature study showing that the percentage of the global population at risk from flooding has risen by almost a quarter since 2000, and it's increased in every region of the UK. that brings with it a requirement. Obviously, there's a risk of drowning, there's a risk of other problems associated with immersion, but there's also a much greater increased demand on our search and rescue organizations to go and rescue people who find themselves in flooded areas. And physiologists have been working in that area to make sure that those who go and rescue people are themselves safe and properly equipped. I've mentioned drowning. There's about 1,000 people a day drown. In the UK, it's one person every 20 hours, a child a week. And this drowning is occurring in every country, but particularly in the third world, and particularly in areas with rising water levels. So as an example, Bangladesh has about 19,000 estimated fatal drownings each year. And that is going to get worse with time, and it's going to drive a climate-driven migration. So the estimation is over the coming 50 years, about 1 to 3 billion people are likely to be living in conditions that are not currently regarded as survivable, and about 2 to 3 billion of those that are under the high tide mark. There will have to be a migration of individuals due to that impact. Just for the last couple of minutes, I just want to drill down a little bit into heat. We've talked about heat. We've had some statistics from Marina about heat, and it's going to be a major component going forward. And there are several heat-related problems. You can see them on the left of this slide: increased cardiovascular strain, increased chances of clotting, direct effects of heat producing hypothermia, heat exhaustion, and heat stroke. And then there's the aggravation of existing conditions: cardiac problems, MS, epilepsy. All of these conditions get worse in a warmer environment. And another often forgotten combination or factor of heat-related problems is diminished workability and productivity. Now, we've seen slides about the groups at risk, and we've seen slides about the frequency of heat exposure. What we know much less about is the actual mechanisms that are impacted in these individuals. And they cover every physiological system, just about: vascular, cardiovascular, gastrointestinal, neurophysiological. And unless we understand precisely what's happening in different groups on these exposures to heat, it's very difficult to design effective mitigations. Some of those mitigations are listed in the third column here. And where we're lacking at the moment is in particular areas such as the impact of chronic exposure to heat waves, for example, a heat wave that goes on for several days and includes hot nights and hot days, particularly on special populations: children, the elderly, pregnant women, for example, those with disability or comorbidities. Now, the important thing about that, although the first column is largely ergonomics and medicine, the next three columns are all pretty well driven by physiology and are in the remit of physiology. And I think this is an area where we need more information. There's some work being done. There's some work funded by the European Horizon 2020 project. Two of the authors which appear in the PhysSoc publication, Professor Jay and Professor Havanith, have been working in this area, looking at the impact of workplace stress on productivity and health of workers. And another chapter within the publication of the PhysSoc is looking at the challenges and opportunities for human thermal resilience. How can we build up human thermal resilience in anticipation of the changes that are on the way? So where does physiology sit within this area? Well, I hope it's clear that an understanding of the disturbed physiology that results from different aspects of climate change is the first step in designing effective mitigations. Those mitigations come in many different forms. But as with other major social challenges and societal challenges, physiology and physiological input is pivotal for optimizing the response to climate change, as it has been recently for COVID, and as it currently is for long COVID. I'll leave it there, I think, Stephen. Thank you.
Mike, brilliant. Thank you very much indeed. Some fascinating insights there. I mean, as politicians, the one that struck me particularly was the idea that, well, billions of people will be moving around the planet trying to escape from extreme weather, 1 to 3 billion within the next 50 years. Is that based upon no action or based upon the 1.5 degree target that we're trying to maintain? And that migration is, how far is that migration going? Is it trying to escape whole countries or areas of countries? Will it be an increase in density in certain places? Or are we going to see more people trying to literally leave continents to escape this?
Well, it depends to some extent, Stephen, on the nature of the immediate climatic threat. I mean, if it's heat, then people will probably, maybe stay put, but there'll have to be some adaptations and some local resilience. I mean, but if your country essentially disappears underwater, you have no option. And that's the projection for somewhere like Bangladesh. That's the projection for lots of Pacific islands, for example, and other larger areas of coastline around the planet. And so that migration will definitely be enforced.
Okay, thank you. So that it's something that we obviously need to think seriously about beyond the scale of a single parliament. It's something that.
Oh yeah. I mean, it'll be, just to add, it'll be compounded by the fact that there'll also be large swathes of the planet where we can't grow crops.
Yes.
So we'll be realigning ourselves according to climatic dimensions rather than maybe even nationalistic ones.
Interesting. Thank you for that. That is very helpful. If I could just remind people that if you have a question you want to ask, please can you put it in the Q&A function of Zoom so that the team can marshal them. And what we'll do is when we get to the questions is I will call you, you'll be unmuted and you'll be able to ask your question yourself. So as I say, please use the Q&A. Right, we will move on to our next speaker, which is Professor Madeline Thompson, Head of Climate Impacts at the Wellcome. So Madeline, very welcome to you. And I believe you're going to talk about how Wellcome is responding to the climate emergency.
Yes, and thank you very much for inviting me for this evening. The first thing, if you could move to the next slide, please, is just for those people who are not familiar with the Wellcome Trust. It was founded in 1936 by Sir Henry Wellcome, a great entrepreneur and pharmaceuticist. And the Wellcome Trust is a politically and financially independent foundation. As of our latest annual report, we have an endowment of 38 billion. We're based in London. And we spend, at the moment, about £1 billion a year in support of our mission. In the annual report, you'll see that the intention is to increase that substantially. So as of October 2020, we have a new strategic plan and a new mission statement. Next slide, please. And this is for those who know Wellcome and know that the Wellcome vision has always been around achieving extraordinary improvements in health by funding the brightest minds. And we've had a very strong biomedical investment. Our new strategy is in many ways a very big step forward. And that is, our new vision is to support science to solve the urgent health challenges facing everyone. And that means we have to think quite differently in how we invest. And the process to getting there was quite long and elaborate. We had a major scientific review between 2018 and 2020. This was in response to the fact that Wellcome's research funding has increased dramatically and will continue to increase for the moment. And in this process, we consulted very broadly, not only amongst Wellcome grantees, but amongst the science community generally, not only in the UK, but internationally. And we asked really, what should Wellcome be in 10 to 15 years' time? And what major scientific health challenges should we seek to overcome? Our priority was really to focus on urgency and scale of the threat, the opportunity for Wellcome to lead the way and make a difference, and the ability to harness what differentiates Wellcome from others, which is our political and financial independence. So it is with that we came to 3 challenge areas that will be the focus of the Trust in the decades to come. And these are mental health, infectious diseases, and climate change and health. And underpinning all of this activity, we will continue to fund what we call discovery research. And that's our where we allow scientists to do if you like, exploratory, blue sky thinking, coming up with new solutions, new ideas, new approaches to understanding how life works, etc. And in addition to thinking through the new challenge area, we want to refine our approach. Our approach is still in line with our review to advance significant science to solve these important areas, and to advance science in general to support human health, and to do this in a more targeted and interdisciplinary way. But an essential part of our approach now is our principles of equality, diversity, and inclusion that will underpin all of our new strategy, as does research culture. And so we want to have the broadest possible range of people to contribute and to benefit from science's potential to change the world. And I'll just say a little bit about our prior investments in this area. Until recently, I was the interim head of Our Planet, Our Health, which was an investment called what we called a priority area under the old strategy. And we had about 75 million pounds to spend over a 5-year period, focusing on global environmental drivers of health outcomes, and in particular, food systems, climate change, and cities. And we made a number of awards, quite a few of them as partnership levels, which were around 5 to 10 million pounds each. And through that process, we have generated a lot of outputs and policy related activities and research and advocacy in over 35 countries and across 6 continents. So this is a quick snapshot of our key partners in this area. You'll note the Lancet Countdown, of which we are very proud. Also the World Health Organization, which we supported through COP26, and these science partnerships that looked across urbanization, food systems, and in particular, and integrated, if you like, climate into that process. We have a lot to have learnt from these investments, incredibly important to fund transdisciplinary research, bringing in different communities to work with each other. But in many ways, the Our Planet, Our Health didn't incorporate so much of our work. Sorry, are you keeping up with my, I do apologize. We need to move on in the slides. If you can move from there, this was the science review and our strategy incorporating the 3 areas. If you move to the next one, please. And these are our principles. And the next one. And this is our historic funding. Now we can catch up with ourselves. Next one, our current partnerships. And what I wanted to say about this is that we really looked at a very transdisciplinary approach, a very systems-based approach, but in many ways, we didn't connect this work to our core biomedical research that Wellcome is so well known for. So next slide, please. In the new strategy now, we not only want to focus on these bigger challenges with more resources and more targeted in particular around climate change and health, but bring in the underlying capability that we have to invest in science in the more molecular and physiological level. So we see this now as an opportunity, if you like, to bring Wellcome's core strengths together with this broader vision of tackling climate change. And we hope to do this through generating and synthesizing new knowledge, developing and evaluating advanced action, and building a transdisciplinary field. Next slide, please. And so our long-term outcomes are very much around the rapid reduction in greenhouse gas emissions in a way that maximizes health and then avoids the negative impacts, limiting global heating to well below 2.2 degrees. And we are now focused on 1.5 in line with the Paris Agreement, and successful adaptation resilience strategies. Next, please. And so what does the future funding look like? We have pledged in our early investments to invest 75 million to accelerate climate and health research. We will be awarding this through a mixture of directed funding and one-off open calls. And we hope to launch or we will be launching our early investments in the spring of 2022. And the first calls that we're investing in are going to be focused on heat. So thank you very much.
Madeline, thank you. Brilliant. Just on that last point, who will be deciding which projects to accept and to fund? Will it be the same panel that you normally use at the Wellcome Trust to make awards?
Oh no, so under these new challenge areas, we will be creating panels for each individual call so that we have the specialists on board that can actually identify the best science, the best opportunity for delivery, etc. Wellcome has a very strong history of ensuring that it's the scientists that choose the science and not the funding administrators. So I have to say that Alan Dangor, who was at the London School, started at Wellcome today and will be leading the Climate and Health Challenge, or is now leading the Climate and Health Challenge. But across all of our open calls, we will be seeking scientists to participate in our funding committees.
Brilliant. Thank you very much indeed, and thank you for your presentation. Excuse me. Right, we will move on to our fourth speaker, which is Betty Usei-Bonsu, I hope that's correct, who's project coordinator, Green Youth Africa organization. And Betty, you're going to make a presentation on how has climate change already impacted the lives of those most affected. So please, if we could have around 8 minutes from you, we very much look forward to hearing what you have to tell us.
Can I be heard, and can you see my screen? Okay.
Yes, we can.
Thank you. The effect of climate change is affecting us, we all know that, disproportionately. I don't only know this by facts or by theory, but I do from experience. My name is Betty Usei-Bonsu, and I'm the project coordinator for Green Africa Youth Organization. 17 years back, I can recall waking up to the sound of drops of water on my head, or a tap from my mother waking me up and telling me, pick up the pails and fetch out the water from the house. And this is when intense rains has happened. We were so excited because we had to leave that particular condition. And what took us out of it was when we had one intense heat wave, and then the whole building, we had a lot of sparks from electrical faulty wirings, and then the building caught fire and burnt down to the ground. And that's how we left that particular facility. This experience has motivated me in my daily endeavors and also led me to work with several individuals in terms of implementing solutions on community adaptation. And this is what I'm doing with my organization called Green Africa Youth Organization. So Green Africa Youth Organization is a youth-led gender balance advocacy group that focuses on environmental sustainability and community development. Over the years, we've worked with several institutions, we've partnered with several organizations, and some of them include the Global Center on Adaptation, the Office of the UN. We also have the Africa Youth Advisory Board for Disaster Risk Reduction. We have the Africa Secular Network, Economic Network. We also have the National Association Disaster Management Organization, and many other organizations we work with. We work with them with respect to these three thematic areas, which include climate change, circular economy, and disaster risk reduction. All these various thematic areas I've mentioned are interconnected. You would ask me how and why. Because when it comes to circular economy, you are putting waste products into loop that, due to their product's existence is contributing to climate change. And from that, you can see the effects via disasters. An example is drilling of oil to make plastics. And from those plastics, you can get oil spillage into the rivers. From those plastics, you can have ineffective waste management where you get a lot of littering in the society. And from those plastics, they could choke gutters and cause flooding. Just an example of a loop I'm talking about. So within my organization, we have projects, as you can see, we have the Trees for Biodiversity, the Youth Climate Council, Local Conference of Youth, Water for Adaptation, Climate Stimulations, and as you can see here on the screen. If you ask me, is climate change happening? I don't think we have to ask that question again. Yes, although, and its effect is being felt not only globally, not only internationally, not only nationally, also locally. In Ghana, it's a multiple-edged sword. And with respect to this particular sword, you experience that in a particular country, you have the effects of climate change being felt disproportionately. For example, here in Ghana, when it comes to climate change, the people we have to say are really the climate change effectors are the northern parts of Ghana. These people are affected so much. Is it the dry weather conditions they have? Is it the impact of rainfall? Now they get one rainfall every year, which is very, very devastating. Here is a particular case study of a project we are currently ongoing in the Upper Eastern region of Ghana. From here, you can see this is a water source they drink from. You can see how polluted it is. You can also see how the lands that they cultivate for the agricultural source, you can see how it is here. These people experience a loss of arable land, which often leaves them with little income generating resources and causing them to migrate to other or the southern areas of Ghana. From our various projects implemented in Ghana, we observed that most of the waste workers that are working in the cities actually migrate from the northern parts of Ghana. This is very, very devastating. And with this particular condition, farming is impossible. There are structures, you can see a structure here. These are what they've been staying with. And now just imagine how increasingly hot the conditions are. The structures are no longer friendly. I love when Mike and Stephen made mention of migration. And this is an example when you face all this kind of extreme conditions, you have to then migrate from where you are. Not only migration is it happening internationally, but it's also happening within regions. And heat waves, Marina mentioned heat waves, and this is a typical example happening over within these areas, and strong winds. When it comes to education, there's lack of education. Why? They lack water. They don't get access to drinking water. So what happens? The ladies, the children would have to walk miles to go and fetch water. They can walk 5 kilometers, 20 kilometers just to get access to drinking water. When it comes to education, these people, they're at the back. They don't get access to education. This is a typical story of a lady telling us one of our projects. And you find them sitting in the house, knitting their way through to get some petty money. If they're not able to get that, they go into deviancy, pregnancy, early teenage pregnancies. Thus, in order to combat or enhance adaptational efforts, GAIO implements solutions or locally led adaptation solutions within communities. And with these particular solutions, we have water for adaptation, we have trees for biodiversity, and then we have sustainable community projects. With respect to water for adaptation, we design, or should I say we harness modern technologies to improve accessibility to water. For this particular project we are currently commencing, we've been doing over there, we are able to provide them with portable drinking water, we are able to increase the accessibility of water for farmers for irrigation of their crops. We're able to expand education within the community. Apart from that, we undergo trees for biodiversity, where we plant trees and indigenous seedlings within this community. Not only are they feeling the effects of it, the climate change, but the hot sun on the skin is just too much within all these areas. Apart from that, we have our sustainable community projects. Here you can see pictures of some of our activities in these areas. Here comes our sustainable community project. With this project, it's been implemented in communities. And then our sole outcome is to reduce waste from landfills, create jobs, bring about more green product development, and also create more awareness. With respect to all these projects, I mentioned from the onset that communities are facing the effects of all this climate change. They're not only facing that, but the products from all the waste that is being generated from extraction, from mining. So Gaia is able to put all these things together. For example, we have the plastic. We all know the plastic is being mined, and then we have them being imported here to Africa and in Ghana. So our potable drinking water are made from sachet water. So with this, we're able to utilize the sachet rubber. You see them over here is being littered indiscriminately. We utilize them to produce products. We train the community individuals to produce products that they sell for revenue generation, which are exhibitions are done. We also
Betty, sorry to interrupt. Can I ask you to sort of start wrapping up, please? Because we're a bit over time. Thank you.
We also have organic waste from communities, which are converted to compost for usage and is increasing crop yields within communities. Here is also a display of some of our works we are doing in terms of the conversion of waste products to renewable products for consumption. We all know that climate change is happening, and it's happening very, very fast. But right now, what we have to focus on is adaptation and how our various little efforts can create changes within our communities. And Gaio is committed to sustainability, and thus we should all contribute and ensure that youth, women, everybody, together, we can provide and create lasting solutions within these communities. Thank you very much.
Betty, thank you. That was excellent. And thank you for all the excellent work you and Gaia are doing to promote climate change across Africa. Is it, how far is your reach? Is Gaia's reach across the continent? Is it, you know, north, south, east, and west, or are you in the process of growing the reach of the organization?
More in the Africa reach, Africa. Yeah. We operate in Mali, we operate in Senegal, Togo, and we are still growing.
Excellent. Excellent. Well, good luck with your mission, and thank you for what you're doing. Okay, we will move on. And if I again remind people to use the Q&A function for any questions you may have, which we will come to in a few moments after we have heard from our next speaker and last speaker, which is Dr. Elaine Malaki. Sorry?
Mulcahy.
Okay, apologies. Interim Director of the UK Health Alliance on Climate Change. And Elaine, you're going to talk to us about the role and ambition of the UK Health Alliance on Climate Change. If we could have approximately 8 minutes from you. Thank you.
Certainly, thank you so much. And my name is a tricky one. It does catch a lot of people out. But thank you so much for the opportunity today. I really appreciate being welcomed here. So yes, I'm the Director of the UK Health Alliance on Climate Change. And I'm just going to talk to you today about really how we're harnessing the power of the health community to have a voice in the area of climate change and health and why it's so important that the health community does have a voice in this area. I'm sorry, my slides aren't moving. Okay, sorry, my slides are just a bit slow. So who we are. So the UK Health Alliance on Climate Change, to give you a bit of background about who we are. So we are an alliance of a number of healthcare professional bodies working across the UK, who all have a common goal to address the health impact of climate change. This includes a number of medical royal colleges, including veterinary colleges, a number of journals, such as the British Medical Journal, the Lancet, various associations, societies, big and small, organizations who've got healthcare, who represent healthcare professionals or who reach out to healthcare professionals. The Academy of Medical Sciences recently joined as a member as well. And to give you a sense of the growing kind of recognition of the importance of that voice, during 2021, we had an increase of 12 organizations joined the Alliance. That was a 67% increase on our membership from previously. And it really is, I think, a good example of the health community starting to say, hold on a second, we need to have a voice, and coming together to collectively have that consistent voice. When we look at all of our organizations and the members that they represent, the UK Health Alliance has a reach of about 1 million healthcare professionals working across the world that we can reach to, and that we try to represent as best we can with that consistent messaging. And why do we exist? Well, as we've heard a lot about today, the climate emergency is a health emergency. It is the world's greatest threat to health. And we've heard so many examples of that from the other speakers today, about the millions of deaths that are happening already as a consequence of climate change. I've put this graph here because I think it's a really interesting comparison. So when the COVID pandemic hit, we were so acutely aware of the immediate threat to our lives from that pandemic. And we know that tragically, millions of people died around the world because of COVID. In 2020, the World Health Organization reports that COVID accounted for about 3 million deaths worldwide. That was 2 million reported deaths and another million of unreported deaths because of COVID. We all felt that. We were all locked in, a lot of us locked in our houses because of COVID, because of the immediate threat to our health. But if you look at the number of people who died from air pollution alone in the same year, it's 8 million people. It's more than double who are already dying every year as a consequence of air pollution. That doesn't take into other impacts on human health of climate change, like extreme heat and flooding that we've been hearing about. It's really significant, but it's been a gradual increase over a number of years. So we haven't noticed it so much. It's been gradual, but we've known for years, for decades this was coming. And this is where we are today. So it urgently needs to be addressed. It is happening now, and it's the greatest threat to healthcare that we have today. And what we also know is while the number of sick people coming to hospitals as a consequence of climate change are stretching our hospitals even further, we also know that our health services are major contributors to global carbon emissions. In the UK, our NHS accounts for 5% of the UK's total carbon footprint. In the US, it's about 12%. So this is something that also needs to be addressed. We need the health profession and our health services need to get their own house in order as well. So they're not contributing and not being part of the problem. So that really essentially is what we do. We are looking at how the impact of action, climate action, can improve health and the health services that we use to deliver healthcare. And the health profession in itself, the people that we represent, they're a trusted profession. It's an important voice. It's a knowledgeable, experienced, expert group of people. They are trusted and, importantly, very connected to other people and the community. The health workforce employs millions of people, and they in turn are in contact with millions of people every day. The power to cascade knowledge and information from a trusted source is such a valuable, powerful thing to own, and the health professions own that and have that. So that in itself is really powerful. We saw the impact of some of that last year through some of the work we did with the UK Health Alliance on climate change in partnership with other groups, including the Lancet Countdown, the World Health Organization, Wellcome, and others during COP26. The first of these was the publication of a health editorial that the UK Health Alliance coordinated. It was published in September. It had two key asks, or two key arguments, and one was about limiting warming to 1.5C, and the second was for high-income countries to do more to address the disproportionate impact of climate change on the developing world. Wealthier nations have caused much of the problem and the position that we're in today, but is other countries who are bearing the brunt of it now, and so they must do more to address that, and transfer of funds to help with mitigation and adaptation. That the impact of that, I've got some stats here. That article between the 6th and 20th September generated 1,166 media stories reaching 2.5 billion people around the world. Really had a huge impact. On the back of that, we launched the Healthy Climate Prescription Letter, which had called for similar arguments. It was a letter that was signed by over 400 healthcare organizations around the world, representing about 45 million health professionals. And it was delivered into COP26 and received by the presidencies of both COP26 and COP27 during the event. That again, during COP26, we saw 17,000 articles on health and climate during the 2 weeks of COP26. That was an increase of 112% on health being reported in the media during COP, which really does demonstrate the impact the health professional voice was being heard and reported on. And just for information, that data has excluded any reference to COVID, because obviously COVID at the time was generating a lot of health media as well. So that's excluding COVID. We worked with the World Health Organization in doing presentations, speaking at COP Pavilion during COP, and this was the first time that health was on the agenda at COP, and it was part of the main meeting. So again, starting to make an impact. And we saw during COP 50 countries commit to take concrete steps to create climate resilient health systems. NHS England already leading the charge on that, and it was great to see the Americans commit to do the same during COP, which was really, really significant. I'm really conscious of the time, so I'm going to stop there. I could talk all day, but obviously there'll be questions at the end I'm happy to take. So thank you so much.
Elaine, thank you very much indeed. Very interesting, and thank you for the work that you're doing. And there were some striking statistics in there. You know, I think I am conscious of air pollution on a constituency basis, because we have quite a lot of national infrastructure running through my part of the world, which leads to poor air quality. But I was struck by the fact that apparently 99% of people live in an area where their air quality does not meet the WHO guidelines. What is the main cause of that poor air quality? Is it industrial activity, transport, or is it poor air quality because of climate change itself and because of rising temperatures?
So pollution is the main cause of the poor air quality. And actually in that graph where I showed you the number of deaths from air pollution, it was two shades in the graph. So I won't try and share my screen again, but so of the 8 million who have died from air pollution in 2020, about half, about 4 million are from ambient air pollution. So that's air pollution in the external environment that we're breathing. The other 4 million are from internal air pollution. And so what you see is in different parts of the world, the impact will be greater. There are a lot of countries in the world where they use a lot of fuel burning in stoves indoors, and they're really damaging for health. And that's a major contributor to the deaths that we see from air pollution in those countries. So indoor air pollution is one cause, and outdoor air pollution from transport, from pumping stuff into the air, the dirty air that you see. There's been so many reports lately about smog and pollution in London, and just last week Londoners being told not to do physical activity because of the quality of air, the air, because of the pollution in the air. So we have that a bit backwards. We should be, you know, stop driving the cars so that people can do the exercise, would be a much nicer message to hear.
Brilliant. Thank you very much. And thank you to all of my panelists and speakers for your contributions. Now, we've got about half an hour for some questions. Now, Elaine, am I right in thinking you've got to go in about 10 minutes? Is that right? I'm
actually okay. Childcare has been sorted and I can stay.
Marvellous. Fantastic.
Thank you.
Great. Okay. In that case, I'm going to ask if any of my parliamentary colleagues want to make or have any questions that they want to put to the panel. Stephen, I can see you preparing by taking your mask off. By all means, go ahead and ask away. Muted. Sorry, that's it.
That's right. Well, first of all, thank you to all the speakers for another excellent series of presentations. I've got two quick questions. One is, has there or does there exist what you might call a map of the areas of the world where, as a result of climate change and increasing heat, certain crops will or will not be able to be grown? And secondly, and this may be for Mike Tipton, in regard to the effect of heat on animals, are there certain categories of animal that you can predict will suffer disproportionately as temperatures increase? And does that affect the bird population and the possibility of migration if heat is too great?
Who would like to take a crack at that? Mike, you were mentioned there.
Yes, I can certainly deal with the second one, Stephen. So you may have noticed from my slides that there are obviously animals living in arid regions are going to struggle, although they are obviously also the ones that have the largest adaptive background. You may have also noticed that, I mean, even if you take a species like birds, for example, there's variation. Songbirds are much more susceptible and vulnerable to mortality during heat waves than other birds. You know, so there's quite a lot of variation. The problem again, it comes with heat snaps. So in November 2018 in Australia, they lost about a third of the population of fruit bats, the speckled flying fox they call them, in just 2 days because of an unexpected heat wave. Is around the Cairns area. So there are definitely variations. But that's almost as if to say in terms of a direct effect on animals. But of course, there's also an effect on the animals they feed off of, which again, it's not just a direct effect, it's the indirect effect of climate change in terms of availability of water, availability of food.
Okay, and is anyone able to talk a little bit about the broader effects of patterns of food production in different parts of the world, both those that could increase and those that would be impossible to grow in the future if temperatures continue to rise?
Marina?
I can talk a bit about that. We do some work on heat and crop productivity, and also about climate change and food insecurity a bit more broadly. And it's quite an interesting issue because that's where a lot of things come together in terms of extreme weather events, increased heat, access to food, labor capacity. And it's, as you know, obviously food insecurity and crop productivity are so multidimensional and are impacted by climate change in so many different ways that it's hard to say, well, this is the actual crop, this is the actual impact that it will have. But what we do have is very robust models that look at how, for example, extreme heat impacts on crop productivity because it makes crops mature too quickly, and therefore crop yields are smaller because the seeds they yield are smaller. So therefore the maximum potential yields of crops is being reduced quite rapidly over the past few years, obviously with those farmers that don't have good access to technology, to fertilizer use, or to irrigation being the most impacted and affected by that. So that is something that we can monitor and model pretty robustly. We also obviously monitor drought events, extreme precipitation events that obviously harm crops as well. And what we're seeing is that in all parts of the world, because of the extreme precipitation and extreme droughts, they're both getting more extreme. They're both happening one after the other. That is starting to damage the soil, leading to more erosion and leading to crop failures already. And one interesting thing about drought is that it's not so much only because of changes in precipitation, but it's actually the drought driven by evapotranspiration, by the increased heat that is leading, for example, in sub-Saharan Africa or in the Horn of Africa to crop failures already because of that extreme heat that scorches the land and leads to extreme evapotranspiration and therefore agricultural drought rather than just kind of lack of precipitation. So it's happening in many different ways, in many different areas, and we can monitor them individually. Pulling all of that together in assessing the whole system of crop productivity is one of the key challenges that we're facing at the moment, how to assess overall crop failure. Some econometrics analysis have already started detecting the influence of extreme heat exposure on reduced crop productivity and crop yields. And we're starting now to be able to pin down what is the influence of heat on crop failures around the world.
Thank you very much.
Okay, and if I can say something, I agree so much with Marina. And if I want to speak from a more local and experienced ground, I would say that an example, a specific example, is a rice crop. Rice crop are known to grow in marshy areas with a lot of water. Now, looking at the enhancing heat waves, causing lands to be more dry, you have this particular crop that are grown in South. You find them to be grown less because now they find it difficult to access water for irrigation to get that kind of marshy areas. So now you will then get more of industry-produced rice crops. So this is what is happening now, where they begin to mix the rice. You don't know which is the true rice, you don't know which is the false rice. So this is a very local example if I want to answer this count. Yeah, thank you.
Thank you very much. Lovely. Right. We will move on to our next question, which is from my colleague, Carol Moynihan. Carol. I think someone will unmute you and you'll be able to ask your question.
Thanks. Thanks very much, Stephen. It was just following on from Elaine's point about indoor pollution. I mean, I'm just wondering, Elaine, how that, what the implications are then for the current fashion or fad for having indoor wood burners. It seems we all get rid of coal fires 40, 50 years ago. Of course, you weren't allowed to burn coal in many cities in the UK, but now we're getting these wood burners that are supposed to be environmentally friendlier. Is that the case? And are we causing ourselves problems?
So,
okay, Elaine.
Sorry. Yeah, sorry to just jump in uninvited there. Apologies. Yes, so they are more environmentally friendly than open coal fires. However, there is certainly evidence to say that wood burners are still impacting indoor air pollution in the UK, in houses here. So there's not been a lot of research. There was a study from the University of Sheffield a couple of years ago, I think towards the end of 2020, that's been reported. I can see if I can find a link. But it did look at the impact of indoor air pollution from wood burners and using dry wood, because wet wood is more damaging, but using dry wood. It was quite a small study, but certainly they did find in that study that there was an impact on health, and it's particularly vulnerable people and children who are more affected. And it's every time you open the door, there's a, the smoke basically escapes into the air, and the more people are loading into the fires, the more pollution is obviously getting into the room. So yes, they are more environmentally friendly, but they're not clean. there, and then within the confines of a small room of a house, you can imagine the impact on that in the air that's being the people are breathing.
Brilliant.
Thanks. Stephen, can I just follow on from that?
Yeah,
then?
of course.
I'm just wondering then, I mean, how do we deal with this? If these are potentially hazardous in the house, I mean, they're hugely popular. Everybody wants a wood burner. They are particularly attractive in rooms. How do we actually deal with that in the context of, you know, health and also our responsibilities globally? You're saying they're more environmentally friendly. Yes, wood is a renewable source if it's properly managed. Are they really a responsible piece of living room furniture?
Anyone want to comment on the responsibility of wood burning owners?
I mean, I can just as a quick, I mean, it's a big question. I mean, it's potentially, do we go to a position of phasing them out? I think starting with a health warning, maybe a place to start, so people are informed and educated about what they're buying and what they're using. It's always a good place to start with, knowledge is power, and people who are informed to make educated decisions will do what's best for their own health generally.
Thank you, Elaine. Thanks, Stephen.
Brilliant, thank you. Okay, we will move on to our next question, which is from Professor Peter Lilford. Peter, welcome. Thanks for joining us. Someone will unmute you and then please fire away. And if you can remind us, all our questioners, if you could remind us which organisation you are representing, that would be excellent. Thank you.
Yes. Hello, can you hear me?
We can.
Right. Peter Lilford, I'm attached to the University of Birmingham. My question is almost the same as Viscount Stansgate asked earlier. We're all aware of the inevitability of climate change now. And I always thought that the primary risk to physiology would be damage to the food supply chain. Now, thanks to the other speakers for broadening my fears of other risks of death, but I would like to follow that up, because obviously there may be some regions of the world where warming, rainfall, and increased CO2 in the air will increase crop yields. Do we have any idea where these regions will be? Because they're obviously going to be very geopolitically important, because by and large, everybody will want to live there. So is there any mapping of local improvements due to the 1.5 degree climate change?
Thank you, Peter. Anyone feel able to comment on that? No.
Okay, well, then all I can do is worry even more and try and engage my colleagues in the food chain to start thinking about it.
Indeed, indeed. Perhaps if you drop that question through to us afterwards, we'll see if we can find someone who can give you an answer. Oh, Mike, you've unmuted.
I'm just making the point that Madeline's got a hand up.
Oh, sorry, missed that. Madeline, you're muted, I'm afraid.
Recognising the issue, there's been a lot of discussion about CO2 and its potential to enhance crop production, but the general scientific opinion is that overall, the damage that Mariana has already described from heat and extreme events will far outweigh any benefits to crop yield. But the other challenge that has also been researched is that even if you get a bigger yield in terms of weight, a lot of that is carbohydrate, and therefore you get a dilution of the vitamins, the minerals, and the important nutrients in the crop. So there's a risk of dilution, if you like, of crop nutrients as a result of increasing crop yield through CO2. And we know that CO2 is used in greenhouses, etc., for crop yield. are there parts of the world where we know that warming will benefit? I mean, for various things, you could say yes. You know, if for North America, Canada, etc., cooler environments where there is large-scale agriculture potentially will benefit. Alongside that will go diseases and other aspects that will also shift. But the biggest risk is that while there might be general shifts in agricultural areas, the risks from extreme events pose a real threat even in those areas as well, as we saw with the heat wave in Canada. So there isn't a great opportunity coming from climate change.
Thank you.
Marina, do you want to make a quick comment?
Yeah, I will just very quickly add on to what Madeline said. I absolutely agree. And just to add something extra is that even in those places where you might have short-term increases in productivity and short-term gains, the modeling that the IPCC has done in the longer term, particularly as we go towards the 2 degrees of warming, is pretty catastrophic all over the world. So that's why it's also so crucially important to aim for the 1.5 degrees moving forward.
Brilliant, thank you. Okay, we'll go to our next question, which is from Mick Devine. Mick, welcome. Thanks for joining us. Someone will unmute you and then fire away, and just please remind us who you're representing today.
I'm not really representing anyone. I'm a firefighter. I'm just interested in the topic.
Brilliant.
I'm familiar with the impact of working in the heat. The UK Fire and Rescue Service workforce is reduced by over 11,000 people since 2010, and that includes a reduction of around 8,000 frontline firefighters. Senior managers have now stated that the public should now lower their expectations that things like large wildfires and floods can be tackled. How will the government mitigate against this reduced capability in the future?
Okay, I suspect that's one for me rather than others, and I think it's a good question, Mick. And without not being a member of the government, I am not best placed to answer that. That said, if you drop us an email afterwards, I will pose that question because I think it's a valid one.
I suppose we could sort of pose it to the panel as well and see what sort of the impacts that they anticipate in the future for emergency services, that sort of thing.
Okay, I don't know if anyone would like to comment on that. Madeline, or is that a historic hand?
No, it's a new one. I just think that what you're describing there is something that is going to occur right across the emergency services. We have now something called managed retreat for coastal areas where we no longer wish to protect homes and businesses that are in areas where sea level rise and will have a damaging impact in the future. So the concept of managed retreat and allowing nature to do its thing is actually not just going to be around fires. It's in other areas as well.
Thank you.
Stephen,
yes.
I would just agree with what Madeline's just said. I mean, all the evidence suggests that there are going to be more extreme weather events. That's going to be associated with more flooding, more fires, and more adverse events that require emergency service support. But that's right across the board. I mean, the Coast Guard's, celebrated their 200th birthday yesterday, and they're busier now than ever. So I think that it's going to be a challenge reducing manpower at a time where we're going to be seeing an increase in this demand. And certainly the work we've been involved in terms of the demand of flood rescue, for example, on individuals, it really is not something that people can do for very long without being able to rotate out and be replaced by other individuals. And that's a manpower issue, as well as a PPE and technology issue.
And of course, a resource issue as well.
Absolutely,
so
yeah.
We'd be adding the costs of increasing emergency services to the overall cost of tackling climate change. That's a rhetorical question, really, but it's obviously there are associated costs of dealing with this. So interesting point. Thank you for that. Right, we'll now move on to Professor Paul Monks, who I think is the Chief Scientific Advisor at Bayes. Paul.
Hi, good evening, everybody. Good evening, panel. I'm kind of interested in the broader question, and it kind of following on from the last thoughts about how we adapt to this. So with respect to climate, we can either take climate change mitigation or climate change adaptation. So how should we be looking to adapt and mitigate the challenges with respect to the health systems that you've outlined this evening?
Who would like to take a stab at that?
Stephen, I'm happy to go first.
Yeah, thanks, Mike.
Well, physiologically, humans don't have a great capacity for acclimatizing to heat or cold, but they do have some. One of the articles in the report that has prompted tonight's meeting talks about increasing human resilience to the kind of changes that we're going to see with increasing cold snaps, increasing heat waves. We've become much too comfortable as a species. We can control our environment to a point where we no longer challenge the homeostatic mechanisms that we need to have fit and ready in order to tolerate some of these things. So that's one aspect, but it's a pretty minor aspect in the great scheme of things. Where most of this adaptation is going to occur, it's going to be in every aspect of our lives. We're going to have to think about, how we move about the place, what transport we use, how we design buildings, what we put into buildings. I mean, we've had a discussion about wood burning stoves, but really that's just one aspect of a complete lifestyle change and climate change being shot through everything we consider. If you go to the report, the very last section is a section written by myself and Prof. Montgomery on the kind of actions people can take at a personal, group and societal level to try and constrain the kind of increases that we're seeing. And it's everything from transport to eating seasonally, eating locally. There are lots and lots of things that are lifestyle and technologically driven.
Brilliant. Thank you, Mike. Marina?
Yeah, just to add on to that, and I absolutely agree, Mike, obviously. It's quite interesting to think about adaptation because it's hyper-local in general. You need to take into account hyper-local habits, hyper-local capacities and possibilities. And it has been quite neglected in the climate change conversation, which is in part driven by the fact that it is the low and the most vulnerable nations, the ones that have had to very urgently adapt up until now. We have been quite lucky in that adaptation until a few years ago hasn't been so urgent for higher income nations. So that will probably be a very big part of what happens in the lineup to COP27 happening now in Egypt, where loss and damage has become really mainstreamed, and the talk about adaptation as well. But it's quite interesting also to hear about adaptation measures that have been taken up in lower middle income nations and that we perhaps have been neglecting. And I think the use of air conditioning is a prime example of that. We immediately, as soon as it gets hot in places where we have more resources, we go to the maladaptation of using air conditioning units, whereby in lower income nations, they have adapted to extreme heat, sometimes fairly well through traditional construction methods and other ways of cooling, like spraying water, damping the clothes, or wearing different types of clothes in very, very hot weather. So it's very interesting to open the international conversation there and really start incorporating learnings from other countries, which might not be so technologically driven as we're kind of used to, but can be also incredibly effective and low cost and essential for saving lives as well.
Brilliant, thank you. I think we will move on to our next question, which is from John Skelton. John, are you with us?
Hello, good evening.
Hello.
Thank you. Hello, and thank you for a fantastic discussion. Yes, my question, I think, is again, it's a bit broad. I'll read it because I wrote it with some care. Solutions to adapt to health hazards posed by climate change could inadvertently increase climate change. So, I mean, how do we as a country, or indeed the world, balance the demands of protecting human health and well-being against the strain we put on the planet? So for me, the question is, how do we ensure we don't do more harm by trying to do good?
Good question. Who would like to comment on that? Madeline, is that a new hand? Yes.
It is indeed. Yes.
Good. Please fire away.
Yeah, so I think what we're looking at is that it's not really human health versus the planet. It's human health today versus human health of future generations. And I think we need to keep in mind that we are, sort of integrated into our environment, and that what we do to the environment is going to come back and impact on us and our children and our grandchildren. And so I think reframing that, I think it's a very good point. We need to improve health, particularly for the vast communities around the world that don't have access to good healthcare, that whose children die from very preventable diseases, which we really should be investing in and protecting. And an example is the electrification of Africa is incredibly important for Africa's development. It's incredibly important for health services to have electricity at health facilities. Now, at the moment, electricity is often poorly supplied by local generators, very, very expensive to the local health services. And we have new initiatives under Solar Energy for All, for instance, about the electrification of health facilities using solar panels instead, where you've got a win for health, and you've got, you're not increasing the burden of fossil fuels. So I think we're looking for those win-wins, but I don't think it's true to say it's human health versus the planet. It's human health today versus human health in the future. And the planet is part of both of those.
Thank you. Excellent. Okay, I've got an eye on the clock and I may well have a vote at 7, but let's see if we can get through one more question. Just before we do that, in case I have to rush off, can I remind people that the link to this very important report is in the chat, and that that has been posted there. So anyone who wants to have a look at it, copy that link now, because obviously it will disappear when we finish the meeting. But let's go to William Duncan for a question. William.
Thank you very much. I represent the Parliamentary Science Information Foundation and also the University of Strathclyde. My question, first of all, excellent presentations, but my question is trying to understand the shape, if we were plotting adverse health impacts against temperature. So are we facing a linear increase in the adverse health impacts due to already inescapable temperature rises, or will the impact be even more severe? And if it is more severe, what will be the main tipping points? I'm just trying to get a sense of that correlation between the adverse impacts and the temperature rises. Thank you.
Thank you, William. Anyone want to comment on William's question?
Stephen, I'll have the first. Unless Marina, did you want to go first? As you've got
no,
your
Mike,
hand.
please go for it.
I think one of the things that's come out of this evening is that we can project and predict increases in average temperatures, and we can see changes in CO2 levels. What we're less capable of doing is looking at the adverse cold snaps and heat waves. They definitely will go up in number and severity and duration, but actually it's much more difficult to say where the tipping point is for those to occur. They're happening already, floods and heat waves and cold snaps, and they're the ones that are particularly impacting on health. We already have something like 20,000 excess summer deaths in the UK, and a larger number of excess winter deaths, actually. So the problem is not projecting the temperature, it's predicting cold snaps and heat waves.
Brilliant. Marina, thank you.
Yeah, I absolutely agree. There's another element to it as well, is that when these things happen, they don't happen in isolation. So you can have a heat wave and then you can have an extreme weather event added on top of that. It's also driven by the higher temperatures. And you can have at the same time a pandemic that might be driven by climate change in the future. And things add one on top of the other. So the interesting things about when we think about health tipping points is that you have to think about the whole systems that determine a healthy life and the whole natural and social systems that sustain us that can all collapse because of climate change impacts. So it's really hard to predict how all of these will interact together. But for example, a clear one is we have seen that the higher temperatures limit our capacity to do exercise outdoors. And at the same time, a lower capacity to do exercise might lead to higher incidence of chronic conditions, the same with lack of food security. And that at the same time will make us more and more vulnerable to extreme heat exposure and adverse effects from heat. So all of these multidimensional impacts of climate change interact to undermine all of the pillars of good health and add on top of each other. So it's really, sorry, someone was saying about the bad news and the worrying. I'm not giving you very good news, but it's hard to predict how all of that will interact with each other.
Thank you for that. And then a final comment from Madeline, and then I will wrap up because we have run out of time. Madeline.
Well, thank you. Just to build on the contributions from the two other speakers, which are perfect, is if you just think about the Canadian heat wave, that was not predicted the last summer, huge heat wave, way excess of normal temperatures, definite information that is climate change driven. It was not predicted by the climate scientists. It was outside of their extreme things. So we're going to see these local events. They're not part of a long-term, the overall process is part of a long-term trend, but we're going to see these very diverse effects in very different places in the world. And that is difficult to manage in any planning process, except if you have flexible, responsive systems that allow you to adapt in a kind of risk management approach, rather than saying we know exactly what the future will hold in any particular area.
Brilliant. Thank you very much indeed. As I said, we have run out of time, I'm sorry to say, because I think it's been an absolutely fascinating discussion, and one which is obviously going to be dominating our collective agendas more and more as we move forward about mitigating the impacts of climate change and tackling the source of it as well. So I'm very grateful to Marina, to Mike, to Madeline, to Betty and to Elaine for their contributions this evening. Thank you very much. I hope you've found it an enjoyable experience presenting to the PNSC, because I know that I and the members certainly have appreciated it. Can I also thank Andrew Mackenzie and Tom Addison from the Physiological Society for their assistance in facilitating this discussion. And just another reminder that the link to the report is in the chat. And of course, a huge thank you to our audience, or review, and our questioners, and the team at the Parliamentary and Scientific Committee of John Slater, Karen Smith, Ben Allen and Alfie Hoare. Alfie will be writing up an account of our discussions, both for our website and most probably for our quarterly magazine, Science in Parliament, which now goes to every member of the House of Commons and the House of Lords 4 times a year. And so the information and the comments that are gathered here are disseminated across the whole of the Houses of Parliament. So thank you for that. A quick reminder that our next meeting will be on Monday the 21st of February at 5:30, and that will be in partnership with the National Oceanography Centre. And the topic will be Rising Seas, the impact of changing climate on coastal communities. So as you can see, the theme continues. So again, thank you everyone for joining us. I hope you've enjoyed it, and I'll see you at the next meeting of the Parliamentary and Scientific Committee. Until then, goodbye and have a good month.